Welcome, dear friends. It is my pleasure to introduce you Professor Curry. And Professor Curry, she's an expert in climate change and in atmospheric science, in hurricane science, and Professor Curry has so unique background, and I would like to welcome you to our conversation, and it's a real pleasure to have you, Professor Curry, with us.
Well, thank you. It's my pleasure to join you.
Thank you very much. And I would like to first, you have so impressive biography, and we really respect your position regarding the climate change. And could you please tell us a little bit about your journey in this climate change science?
Okay, when I was a graduate student in the 1970s and the 1980s, climate change wasn't a big deal. There was no field of climate science. You studied atmospheric science or oceanography or geochemistry or whatever. My PhD thesis was on the subject of cold core anticyclones, the very cold air and the cold in the Arctic and Siberia and in North America. And that was a topic of my thesis. And I continued doing my research on the Arctic for a while. And then when climate change became more high profile, the Arctic was a really big deal. So I naturally sort of moved into the climate area. And then my interests broadened out into other topics, clouds and the cloud feedbacks and radiation and sea ice. And I also became interested in extreme storms, extreme weather, and hurricanes, and whatever. And all of this was before I ever thought much about climate change. I just did my research on these topics. I inadvertently got pulled into the climate change debate in 2005. And 2005 was when Hurricane Katrina struck New Orleans in the US, causing huge devastation. And just by a pure fluke, we had a paper published in Science a few weeks after Hurricane Katrina saying how we had observed the proportion of Category 4 and 5 hurricanes to be substantially increasing in recent decades. And so this was related to increases in sea surface temperature. And then people saw this as a big global warming focusing point because for the first time they saw a real hazard that could be associated with just maybe 1 degree of warming. And so I got pulled into the climate change debate as a result of that paper. And I was asked to give lectures and provide congressional testimony and media interviews. And it was just a huge disruption to my academic research and my academic life. And at that point, I realized that, look, I don't know enough about this whole issue of climate change. It's so much to wrap your head around. Individual researchers just know a little tiny piece, but it's a huge undertaking to wrap your head around the whole thing. So I started cautiously trying to understand, all the different facets. And then the next big event was really in November of 2009. And this was the so-called Climate Gate that you may have heard of, which was the unauthorized release of emails from a university in England that really showed all sorts of skullduggery, scientists trying to attack each other and sabotage editors and, all sorts of things. And that was a real wake-up call to me because before that, I was, for the topics that I hadn't personally researched myself, I was trusting the IPCC to provide an appropriate assessment. And then after reading those ClimateGate emails, I said, no, if this is the sausage making that is producing this consensus, no, I can't trust this. So, I need to really dig deeper myself into all of these topics and try to assess them and understand them. And at this point, it was really a sea change in my academic life, because I put my own personal research on hurricanes or sea ice or whatever on the back burner, and was trying to understand this whole mess that we'd gotten into with, scientists behaving so badly and the science becoming so politicized. And so the research that I started doing was really more philosophy of science. And I published, say, I think 5 papers, in that series on, sort of the philosophy of climate science and trying to understand the politicization and how we were reasoning about uncertainty and all these kinds of things. And this put me on the wrong side of the activist establishment scientists. Okay, all this talk about uncertainty, no, this is not helping the cause, and so I got sort of tossed out of the tribe and people started calling me a denier and all of this kind of thing. Then I got thrown in the camp of the so-called skeptics or deniers, which is really kind of pointless because I deliberately have tried to keep away. I'm thinking for myself. I'm not joining forces with anybody. And so I developed a new network, of people to interact with. Some geologists, some lawyers, some philosophers, engineers, software engineers, statisticians, social psychologists, people from all sorts of different fields who were thinking, this is really a broader problem, than what has been portrayed. And so I have my own little group of independent thinkers. It's not a tribe because they don't talk to each other. I just talk to them. So I just, after I was thrown out of the tribe by the mainstream climate people, I formed my own independent peer group. I started my blog so I could climate, etc. at judithcurry.com so we can have a discussion about all those really uncomfortable issues that most climate scientists would like to throw under the rug or ignore. And very shortly after that, my position in academia at the university became very uncomfortable, So I resigned my position, and I have my own company, Climate Forecast Applications Network. We do weather and climate research and also provide predictions. But the point is I'm free. Okay, I'm free to be who I am. I'm free to work on whatever I want. I'm free to say whatever I want. And so, I'm happy and I feel like I can have a meaningful impact, outside of academia and the university, just, through my blog and my company and through interviews like this. So I'm in a much happier place. And my goal is to provoke people to think more broadly about the climate change. And we get locked into, we fetishize these numbers and these targets, these emissions targets and whatever. And we lose sight of the goal that all of this is supposed to be about improving human well-being and the well-being of ecosystems. That's what should be the end game, not these targets. Oh my gosh, the 1.5 degree target. People make such a fetish out of this. Well, we've already warmed 1.2 degrees and nothing horrible has happened. What's all this angst, code red, and all this stuff that we're hearing about over a 1.5 degree target? What does that even mean? It's just like a made up target trying to torque the politics of the whole thing. So,
Judith, what is going on with the climate? I won't be lying if I would say that we questioned over 100 scientists from every camp there is, and some of them are saying that CO2 is changing the climate. Some are saying that CO2 has nothing to do with the climate.
Climate started warming in the middle of the 19th century. Centuries prior to that, we were in the so-called Little Ice Age, when it was very, very cold and not very pleasant. And we started coming out of that in the middle of the 19th century. And at this point, Little Ice Age, coming out of the Little Ice Age, this was all natural variability. CO2 emissions were very small at that point. So what was going on? In the Little Ice Age, there were a lot of volcanoes, there was some low solar activity, and the ocean circulations, they all conspired, to produce the phases of the Little Ice Age. And in terms of coming out of that, again, it was heading into a grand solar maximum in the 20th century. That helped the warming. Relatively low volcanic activity since 1850. And also the ocean circulations been organizing to help some warming. So the warming that we've seen since the mid 1800s has been in fits and starts. We saw a lot of warming, like in the early part of the 20th century, and then in the 40s and 50s and 60s, it cooled off, and then things kicked back in, in the late 1970s, and we've been generally warming ever since. Although in the early part of the 21st century, it was pretty flat. So you have a lot of natural climate variability in play. But on top of that, you have CO2 emissions. The CO2 does produce a warming impact, but it's against a background, of all this natural climate variability. So when the IPCC makes its projections about what's going to happen in the 21st century, the only thing that they include is CO2 forcing. They're not considering that it looks like we're heading toward a solar minimum in the mid 21st century. They're not paying much attention to that. They don't look at the 20th century, the last 150 years have been very quiet in terms of volcanic activity. If you look at what happened, over the last 2,000 years, there have been periods with extremely high activity, including early in the 1800s, from about 1810 to 1840, crazy volcanic activity. That can happen. And then they also downplay the large-scale ocean circulations, which really is the flywheel and the memory of the climate system. And these undergo oscillations from multi-decadal to 1,000-year timescales. And based on my analysis, it looks like for the next 30 to 50 years, we may be heading into a regime where all of this natural climate variability will have a cooling effect. You add that to the global warming, and maybe it will be relatively flat, but this is being totally discounted by the IPCC and people who make these projections. We have to understand this overall warming from CO2 against a background of natural climate variability. And it's the natural climate variability that produces pockets of extreme weather events, whether it's, droughts or heat waves or hurricanes or big floods. Any warming from CO2 provides an incremental, at most, change to these things. The actual events are produced by weather and climate scale circulations in the atmosphere and oceans. So this whole CO2 thing is overplayed. It's a real effect to say that it doesn't impact the climate. That's not right either. But natural climate variability is at least as important, and that gets largely neglected.
Can I sum it up a little bit? So basically, we do have climate change, we do have increase in catastrophic activity, but human effect on it is minimal, right?
Maybe not minimal. We don't know. I mean, people haven't been asking the right questions. I mean, I think it could be the human effect could be 50%, or more. It's not 100%, but it could easily be 50%, maybe as much as 70%, maybe 30%. We don't really know. People aren't asking the right questions. And we don't have enough understanding, really. We know how volcanoes impact the climate. We don't know so much about how solar variations impact the climate. There's a lot of indirect effects that aren't included in the models and aren't fully understood. So until we really understand the solar impacts on climate better, we can't really say how much of this has been sun versus how much of it's been CO2.
What is the danger of the misconception that humanity influences the climate with CO2 emissions? Like, why is it wrong to blame everything on people?
Okay, the only real impact that's unambiguously associated with warming is sea level rise. Okay, and that's a slow creep. For the last 100 years, global sea level rise has been about 8 inches. And that's been accelerating in recent decades, whether that's caused by CO2 or whether it's associated with something going on in Greenland, associated with the Atlantic Ocean circulations, is open to debate. We don't know, but we're talking about a slow creep. But there's all these scenarios out there of crazy collapse of the West Antarctic ice sheet, which would, increase sea level rise by a whole bunch. There's also the air can hold more water, so you would expect heavier rains when there's a big storm, and that makes sense. Okay, but overall, the world needs more water. So if you can figure out how to manage the heavy rains, then you could overall be better off. Okay, so I think whether warming is dangerous is the weakest part of the whole argument. Okay, but then it's the solutions. A lot of the solutions are more dangerous, than the problems of at least the near-term problems of climate change. That this rapid transition away from fossil fuels, is leaving people in Europe with already rolling power outages. It's not a good thing. And this is not to mention energy poverty in places like Africa and South Asia. And, the simplest thing for them to do would be coal. So, there's a whole host of issues. Right now, it looks like the cure is worse than the disease. That's what it looks like to me.
I'm 100% behind you on that point. We spoke to a few scientists, and some of the IPCC scientists also say that, they claim that CO2 is changing the climate, even though we spoke to, very many people who don't believe that actually, and they do have valuable argument behind it. But they're saying that besides the CO2, there is such thing as the like you said, solar activity, solar minimum. We are at solar minimum at the moment, and they projecting it to be at least until 45 or maybe later. And they say there is such thing as cosmic rays, gamma rays, which could ionize the atmosphere and cause more cloud formations, which would cause cooling as well. So if you talk to climate realists, many people actually worry that we are going into ice age in some years forward rather than warming. Do you agree with that?
Well, like I said, I think the natural climate variability looks like it is trending to cooling, in the 21st century, especially, like in the mid-century region. But if you add that on top of CO2, maybe it will all be flat. I don't know, exactly the magnitude and how it will play out. But I agree that there is a cooling trend from, solar and the ocean circulations. And even with a more average volcanic eruptions would be cooling. So I think there's an element of truth to that natural climate variability will push us in the direction of cooling. But how the relative magnitude of that compared to CO2, we don't quite understand yet. So, but I think we will. I think the people who are expecting us to pass the 1.5 degree target by 2030 and the 2 degree target by 2050, I think they're going to be surprised. We're not going to meet those warming targets anywhere near as quickly as they think we are. So,
do you think IPCC is doing their job? Are they really worried about the climate, or is it just politics these days?
Okay, I think the new assessment report, AR6, they've so far published the Working Group 1 report on the physical basis for climate change. This is far and away the best of the reports. It's the most intellectually sophisticated one. This is much better than previous reports. I mean, if you just look at the summary for policymakers, or worse yet, just listen to what the UN officials have to say, then it's alarm, alarm, alarm. But if you actually read the reports, that there is some good stuff there. The thing that they really give short shrift to in the Working Group 1 report is the solar effects. They acknowledge that there's more uncertainty in the historical record than we previously thought, and then they adopt a low amplitude reconstruction as the basis for their 21st century projections. So they really downplay solar in the 21st century. But overall, this report is better, and in many ways, it's a lot less alarming than the AR5 and certainly the AR4. But you'd never believe that from the hype that you hear from UN and other government officials.
A little controversial question for you. The Montreal Protocol apparently fixed the ozone layer. The dangerous chemicals were banned and so on, and ozone layer is supposed to be fixing, but we see new records above Antarctica and so on. So it seems like ozone layer is not affected by whatever chemical was stated in that protocol. What do you think about that?
The so-called ozone hole came back with a vengeance, like, oops. And that it's clear that there's a lot of natural variability involved in that stuff. It's not just about chlorofluorocarbons, in the same way that climate change isn't just about CO2. So I think that was a little bit of a wake-up call. It's certainly downplayed in the media. Oops, there was more going on up there than we thought. It's just not controlled by the CFC. So it's an illustration that, the whole climate system is way more complex than these simple narratives, that it's CO2, it's chlorofluorocarbon. There's a lot more going on.
What we are trying to do, we're trying to figure some things for ourselves. And when we look for the data, it seems to be contradicting each other, depending on the source. One people would say it's warming, the others would say it's cooling. One people would say the earthquake activity is rising, the others will oppone it. The same with volcanoes. What's going on? Why it's so hard to get true data these days?
Well, the Earth system is very complex, and we should embrace that complexity and try to understand it. And disagreement is what fuels scientific progress. An argument is sort of how we, evaluate, each other's theories and ideas, and it's how we eventually move forward. The problem is when all this gets politicized, okay, then the politicians want an answer. Scientists can go off and do their things and argue and follow different tracks. And, eventually somebody will, come up with some ideas that stand the test of time. We're not there yet in the climate system or our broader understanding of the Earth system, but the politics of the situation are forcing us into these little boxes. And so, we're in a situation of deep uncertainty. And the way you deal with that is you just allow the disagreements and whatever to take place, and you try to come up with solutions that are robust and make sense no matter who's right, and overall are focused on increasing human well-being. I mean, we need, cleaner, cheaper, and more abundant energy sources. Of course we do. Should the only priority be CO2 emissions? No, there's all sorts of other pollution and land use and ecosystem issues that we should worry about when we're trying to come up with solutions. So there's lots of motivations for moving away from fossil fuels at some point. So it doesn't need to be driven by the CO2 thing and the perception of urgency. The same thing with water. We either have too much or too little water, sometimes the same place in different years and whatever. So we need to figure out how to manage our water resources, with reservoirs, dams, whatever, groundwater replenishment. We need more comprehensive water management plans. Okay, well, once we solve that problem, we have more water for agriculture. We don't have the floods and whatever. And energy, thermoelectric power plants, whether they're solar or nuclear or fossil fuels, they need cooling water. So we need water for power. That's sort of an underappreciated use of water. So we need to find solutions that make sense overall for human well-being, no matter who is right about the science. So, once you sort of get out of that mindset where you have to have an answer, I mean, these things, not only are some of these things unknown, a lot of it's just unknowable. Okay, we can't, we're not going to be ever going to be able to predict volcanic eruptions and so on. So we just need to accept that and make what progress we can with our scientific understanding, get it unfettered from the politics, but then try to talk about solutions that make sense. We need a vision for 21st century infrastructure for energy and water and transportation and food systems. Let's envision and think boldly about what that should be like, rather than dropping everything and urgently trying to meet these crazy emissions targets that's going to make everybody worse off. So, we need bold visions, and we don't need these 2030, 2050 deadlines. Let's develop new technologies and come up with some real visions. And, each country, each state can experiment, and we can see what works. And this is how we're going to move forward in the 21st century, not by these draconian top-down UN type emissions targets and deadlines. I mean, that's not going to help anybody. It's not going to work, but in terms of trying to make it work, we're going to be much worse off.
Yeah, thank you, Professor Curry. And this, your message, it is really resonating with me. And it's during the conference, we essentially we so much agree, and we are given this message that it is a time in order to look at the picture, at the broad picture, and it's a time to unite our resources and to find solutions. So, and we think that just the joint work of the scientists and kind of our together consolidation as a people is very important, so that in order that we as a society would transition to the solving problems and not talking about these temperature targets. So like putting people first, people well-being first, that's really important. And like, so I have a lot of questions, essentially, like how you're talking about the new energies. Do you have in mind different kind of energy?
Well, okay, in 2005, okay, the solutions look like fracking, hydrogen, and carbon capture and storage. That's what the solutions look like. Okay. And now in 2021, the solutions look like wind, solar, and batteries. Okay. In 2030, the solutions will look very different. The wind, solar, battery solution, I don't like it for so many reasons, which I won't go into here. But for the things that are on the table right now, I think the Generation 4 nuclear power, the small modular reactors, thorium-based molten salt reactors, I think those are a marvelous solution. They've been shown to work. We now need to produce them at scale. You can't build bombs out of thorium. You can recycle the thorium, so you get rid of the nuclear waste problem. The land use is like a very, very small fraction of what wind and solar do. There's, the ecosystem impacts are extremely small. There's no air pollution. I mean, these are good solutions. The other one that I like is that there are new geothermal technologies that I think could be, we have to see where they go. Those are not so much ready for prime time as the small nuclear reactors, but I think there's potential there, with the advanced geothermal. But my point is, 10 years from now, there'll be all new things on the table. Okay, so you don't forever want to be putting off using these technologies until something better comes along. But you shouldn't get rid of your existing power plants, until their natural life cycle. You've got people, at least in the US, decommissioning the existing nuclear power plants. And then they think they're going to replace it with wind and solar. But no, it ends up being fossil fuels. And this winter, it looks like even coal. People are having to use coal. So it makes no sense to do that. And if you have coal is really the worst for the environment. Apart from CO2, there's all the particulates and mercury and whatever. Then there's the mining, the mountaintop removal and the coal ash. And it's just really bad for the environment. So moving away from coal, that should be the top priority. I think natural gas is a great fuel. We should keep using that until we really don't need it. But, transitioning away from coal, like building more coal plants, unless it's in Africa or something like that, a region that is so, energy impoverished and there aren't any other good solutions. Apart from Africa, I would say, come on. Oh, India is another country that's very heavily reliant on coal. That's very tough to move them off it. But again, that there are a lot of energy poverty there also. And coming up with a plan to help India with, nuclear reactors, gas, whatever would help. But I see Africa and India as the two big places where, coal is either entrenched as in India or the quickest, easiest, cheapest solution for Africa. So, but there's no reason that, I don't know, but it is what it is. And I think looking at the broader environmental and human and ecosystem health impacts on all this is, important to do. Like winter, even 20 years ago, we had, at least in the US, all these endangered species, and you had to have all these environmental impact, and the spotted owl, this was going to interfere with the habitat for the spotted owl, and you can't go ahead with your project and all this kind of stuff. It was a little bit overboard in the US. But now we have wholesale slaughter of raptors, eagles, and vultures, and whatever, by the wind turbines. I mean, they're just slaughtering them, all these huge, big birds. And the environmentalists don't seem to care. I don't get it. So
it's a double standard of sorts versus CO2 and, let's say, usage of resources is bad, and green technology, they giving a blind eye on what it does, actually.
I know, and the so-called, the other thing that really irks me is thinking that burning wood pellets, is renewable or green. Okay, so in the U.S., we have big forests in North Carolina are being chopped down, made into wood pellets, shipped over to England, where they're then burned. Okay, and then the UK claims some sort of renewables credit for that. Now, what kind of sense does that make in terms of, even if your concern is about CO2, it just makes the whole CO2 situation worse. Burning wood and shipping it from across the Atlantic, it makes no sense. So again, people lose sight. They get these targets and these definitions, and they lose sight of what the real goal is here. It's crazy.
Yeah, and when we talk about that, I really like green oil. That's the newest invention. When they buy some, I don't know what are they actually buying to say that this oil becomes cleaner than the rest of it because we spend some money on green technology because of it.
Okay, well, in the U.S., I forget what the percentage of the corn crop, it's a lot. I don't know, 30, 40%, I don't know, goes to producing corn ethanol, which then gets added to gasoline for cars. Okay, so what good does this do? Not much. What harm does it do? It raises the price of corn for agriculture, and it depletes our soils, of nutrients, just to produce. It's bad enough that it's sort of depleted for agriculture, but, that's sort of a trade-off unless, you're farming very carefully. But to do that soil degradation just for biofuels makes no sense. Another thing that makes no sense. And does it help it doesn't help the CO2 situation.
We just listed quite a few things, stupid things which are done, and which are counterproductive. Let's say. Don't you think it's somebody is benefiting, like political benefits? Maybe somebody making huge money on it. The farmers in the Midwestern part of the U.S. are benefit big lobbying for corn ethanol because it gives them a much more stable income than agriculture does. Okay, so all of these things, politicians have invested and people have invested in wind farms and solar. And so, green energy, the so-called green energy, is big business at this point. In the same way that the petroleum companies, are big business. But okay, nuclear most definitely is not big business at this point. It needs to be big business, in my opinion. But yeah, everybody, you get financial and political interests entrenched, and then, with these counterproductive solutions. And then it's very hard to say, oh, we're not going to do that because it's entrenched.
Yeah, thank you very much. I would like to come back a little bit to the term which you're using. You're talking about the climate variability. And could you please explain what do you mean by this term, and just maybe some more thoughts on this climate variability? What does it include?
Okay, well, there's three main sources. One is solar, one is volcanoes, and the other is the large-scale ocean circulations. Volcanoes is the easiest to understand. We occasionally get big. It's the explosive ones that make it to the stratosphere, okay, that are ones that impact the climate. And the most recent big one that we had was Pinatubo in 1991. And in the last 2,000 years, we've had maybe on an average of about 2 Pinatubo scale eruptions per century. Occasionally, we get these clusters of explosive volcanoes. Tambora in 1815 was a huge, crazy one, and they refer to that year as a year without a summer. There was agricultural failures, and it was a huge, big deal. But there were about 4 explosive volcanoes, within a few decades, and this really caused a cooling effect. Okay, so like this Tambora crazy size, I guess there's about maybe there have been 2 of those in the last 1,000 years. The other one was in like the 1300s. It was even bigger than Tambora. So we've had 2 of these crazy big ones in the last 1,000 years. So these are wild cards. You can't predict them. They're just climate wild cards. Okay, now let's go to the sun. We have the 11-year sunspot cycle that everybody's familiar with, but sometimes you get periods where you get clusters of higher cycles or lower cycles. And about every 500 years or so, you get a grand solar maximum. Okay, and we had one of the biggest ones in 2,000 years in the second half of the 20th century. Okay, so why do people think that this didn't affect the warming? Of course it had to. How much, we don't know, because we don't understand all those indirect effects, like the cosmic rays and all this kind of thing. And then we have minima. The last big minimum, we have grand solar minimum. There's on average, 2 every 1,000 years. The last big one was the Maunder minimum in the 1700s, and this occurred during the Little Ice Age. It was certainly part of what was going on there. Now, people try to predict these maxima and minima based on their understanding of the cyclic behavior of the sun. And there's also solar dynamo theory, which is you can use to make projections, but our understanding is really not quite ready for prime time in terms of, projections. So the thinking is that we're heading towards some sort of a minimum in the 21st century, and that it's maybe a 10% chance that it could be like a grand minimum. Okay, so this should have some impact on the climate. The magnitude, we don't know. Now, the most complex and maybe the most important is the ocean circulation systems. What do I mean by internal variability? Well, everyone's familiar with El Nino and La Nina. Okay, these are short-term events, but there's also like these multi-decadal envelopes, like big circulation patterns in the Pacific and in the Atlantic. And they're also, the Pacific and Atlantic are connected in this variability through the Arctic Ocean. Okay, so there's sort of like what appears to be an oscillation, nominally 60 to 80 years, where it impacts global temperature, it impacts Greenland mass balance a lot, it impacts the Arctic sea ice, it impacts weather patterns, the whole works. So again, since 1976, we were in this sort of more warming kind of period. And then, in the maybe 2001 or so, shortly in the new century, we're sort of shifted into a different phase of the oscillations, where it looks like we're heading toward more of a cooling. Especially the Atlantic multi-decadal oscillation is a big factor in driving this. And we've been in the warm phase since 1995. Again, the biggest signal of that is a lot of Atlantic hurricanes. but it impacts temperature, it impacts drought patterns, it impacts all sorts of things. So, over the next decade, would expect to shift to the cold phase of the Atlantic multi-decadal oscillation, which should slow down the melting of the Greenland ice sheet, give us a break from Atlantic hurricanes, and it will change the rainfall patterns, especially in the US and Western Europe. So that's a big change from natural variability that we could see in coming decades. And maybe later in the 21st century, we would resume more of a warming pattern from the ocean oscillations. And then in the southern hemisphere, they're longer one. There's 300-year kind of oscillations that influence very much what's going on in Antarctica and how the ice sheets are behaving and whatever. And this is really a dominant signal in the southern hemisphere, which really isn't warming. The sea ice isn't behaving like the climate models expected. There's really no trend. There's big changes, but really no big trend in Antarctic sea ice. And the big part of the continent actually seems to be cooling. So, the very big controls on climate from these big ocean circulation patterns, and even more than 1,000-year, 10,000-year timescales, they come into play. So these are very important. Yeah.
So cyclical, basically natural cyclicity is causing most of the changes. That's what you're saying. Okay.
Yeah.
Okay. Have you heard what do you think about geothermal flux, which was found on the Antarctica, on the Greenland, and warming of the ocean along the Atlantic and the barrier ridges?
Well, this is almost totally ignored by climate scientists. The fact that, there's geothermal heat flux. I think it contributes some to ocean warming. I think it's a very big deal in what's going on with the West Antarctic ice sheet. This is the one that's unstable and the one that could cause crazy sea level rise. But there's all sorts of active volcanoes, underwater volcanoes, and even volcanoes under the ice sheet, that seem to be active. And even if they're not active, they are providing, a steady heat flux that's melting this from below. So, if there were something weird to happen with the West Antarctic ice sheet, I would say it's more likely to be from geology than from CO2, in the atmosphere. So I think this is very, very underappreciated in terms of what's going on with the ice sheets in particular.
A few days ago, we spoke with Dr. Viterito, and he's actually wrote a paper on the geothermal flux and how it influences the warming of the ocean.
And I think another change, which is very puzzling, it is the weakening of a magnetic field, which is observed. And essentially, like our magnetic field, it is our protection from the cosmic rays. At the same time, like it holds the atmosphere. And do you think do you know if some works are related to that also in progress, or it's another ignored factor?
Okay, well, I lump all the magnetospheric type stuff into solar indirect effects. The Earth's magnetic, okay. There's solar magnetosphere kind of, okay, Earth's magnetosphere. The Earth has a very complex magnetosphere. Unlike some of the other planets. And when I talk to planetary scientists, they say, of course, the planetary, magnetosphere has a big control on the climate. And they say, why isn't anybody worrying about that for the Earth's climate? Well, the planetary scientists think that the Earth's magnetosphere is too complicated for them to model in the way they've been doing the other ones. And then the climate scientists, they don't care about anything other than CO2. So I think it's something that, it's one of those known unknowns. Yeah, we can put a name to it, And it makes sense that it should have an effect, but the effects are really unknown. I mean, people should be paying more attention to this.
And may I please ask you also? So you spent really a lot of time studying the hurricanes, and you are predicting the hurricanes in your current weather predicting company. And we would like to ask you if you see any changes or any trends recently with hurricanes, or all is looking the same.
Okay. Hurricanes cover a huge range, and even just looking at, recent statistics since 1950 doesn't give you a full picture. And I'm going to focus my initial comments just on Atlantic hurricanes because that's mostly what I've studied. But, if you go back, a lot of the worst hurricanes, were way, way farther back. A lot of really bad ones in the 1800s, even in the so-called Little Ice Age, there were a lot of really bad hurricanes. So they don't seem to be solely tied to temperature. They're seasonal, they occur in the warm tropics, but, it's more a relative temperature rather than an absolute temperature that they seem to be tied to. There's no overall trend. There's a slight decrease. If you look at the global number of hurricanes, there's a tiniest decrease in the number of total hurricanes, and there's a tiniest increase in the number of major hurricanes, category 3 and higher. Okay, is that global warming or is it natural variability? We don't know, but in any event, it's tiny, compared to the natural climate variability. There are two impacts that seem to be real. Okay, one is the slow creep of sea level rise. Okay, this is going to add an increment to the storm surge. Okay, but it's just like it makes a storm surge, worse by a few inches. It's not going to make a whole big bit of difference for a 20-foot storm surge. The other one is, seems to be more rainfall with hurricanes. And that's part, they seem to be wetter overall, not all of them, but mostly they seem to be wetter. And this does make thermodynamic sense, with a warmer climate. Not every hurricane, it's hard to see a trend in this because there's so much variability between individual hurricanes and individual locations, but it makes sense that in a warmer climate, you would get more rain out of a hurricane. There's a lot of other stuff about they're moving slower over land or they're more further to the north. There's different interpretations on all of those things in terms of methodologies, and the signals are very small in any event, so I wouldn't pay much attention. There was a paper published like last week. There's going to be more hurricanes hitting like northeast U.S. coast, New York and Massachusetts and things like that.
We've seen increase in non-tropical hurricanes along the coast of Alaska, like the winter ones. We had the 2021 started with a double trouble one, category 5, and they are not categorized, even though it's strange to me, and they made a landfall in Alaska. That's one thing. Now we see these atmospheric rivers going crazy on Oregon, Washington, and in Australia, they seem to have the same problem these days. Now, same look at the Mediterranean, how many tornadoes, and now they go in duplets, triplets, quadruplets, and they make landfall as well.
Okay, well, the atmospheric rivers is a good topic, actually. These are big storms that, they last, they're very predictable. You can see them coming, weeks in advance. They're very predictable. But most of my understanding is related to the ones that strike the North America West Coast. And there have been some crazy, crazy big ones. There was a huge one there was a sequence of several in 1861 to 1862. okay? And it estimated over a period of like a month, 10 to 15 feet of rain fell and flooded in the Central Valley of California. Crazy, crazy floods. And you say, oh my gosh, that's unimaginable. Well, apparently, there's usually, on average, about 2 of those big ones per century. And the one in 1861 is one of the smallest ones in the record, of these huge ones. So these are huge, huge storms. Again, 1861, nothing to do with CO2. Okay, well, what is CO2 going to do to these storms? Well, it's going to make them a little bit wetter, maybe by 10%. But, okay, whether it's 10 feet or 11 feet, either way, it's a catastrophe. The fundamental cause of the catastrophe is not global warming. But this is one instance where I think it's credible that global warming would make these a little bit worse. There's debate about whether they would make them more or less frequent. I don't know. But once it does occur, on average, they would probably be a little bit wetter. But yeah, this is one thing where I can see, it's making the existing storms a little bit wetter. I think that's a real impact of a warming climate. It makes sense. It's hard to sometimes collect statistics because all storms are different, So, and then you have to test it with models, and then you don't always believe the models, but it makes simple thermodynamic sense that storms like this would get wetter. Not more frequent, conceivably even less frequent, but when it occurs, they could be a lot wetter. And we need to prepare for these, crazy big storms. I mean, and California is trying to prepare, like, how do we manage all this? Well, we know it's going to happen. And at this point, I would say it's more likely than not that they will see one of these storms, in the 21st century. So they need to figure out how to manage their water. And it's an engineering problem. It's manageable.
Let me, another question, but also I would like to state my position. I believe in climate change. I do see changes, but I personally don't see how CO2 affects it. I honestly don't. But we've heard theory, and we are believing it as well, because we see tornadoes, like where I'm at, Eastern Europe, right? We usually don't see tornadoes here, and now they hear like every other week we have a tornado, which is very unusual. The wind strength is going up. It's definitely so, because 5 years ago I wasn't worrying about the wind at all. Now I have to tie everything down in order for it not to be blown over to my neighbor and so on. So
okay, well, that's pretty interesting. Go on.
Yes, the theory behind it is, since I'm on the land, it has nothing to do with warming of the season. Maybe I didn't see the warming trend as far as temperatures go, but apparently stratosphere is getting cooler and getting lower as well. So one of the variables which plays effect is not the heat going up, is cold air coming down, which could also force the same effect on tornado, because difference in temperature would play the role. What do you think about it?
Well, tornadoes, it's interesting. In the US, we see a declining trend in tornadoes, especially in recent decades. The IPCC does not find any meaningful trend, or I'm just unaware of any papers that have, done a theoretical, physically kind of reasoning to figure out why there would be more tornadoes. I don't see it. The issue of winds and wind gusts, again, I have done some research on that, but it's been focused on the US and Japan. I've looked at some global stuff. 10 years ago, there was a lot of talk of global stilling. It looked like that the winds were decreasing, and the wind power people going, oh no. Okay. That seems to have turned around. like maybe 2012 or whatever, now we see slight increasing, and now people realize, well, what they were seeing, it has to be some sort of multi-decadal natural variability, and that's what it is. But there, the theories that were put forward, well, the Arctic is warming faster than the tropics, therefore the pole to equator temperature gradient is lower, so that should slow down the winds. But if you look in the upper atmosphere, you've got more convection in the tropics, and you've got more of a slope. So it looks like from the top, upper troposphere, you would be driving more winds. So maybe these two things cancel out, and we're not really changing the winds so much, at least in a hemispheric way. But that doesn't mean there couldn't be some local or regional issues. So I'm interested. If you send me an email, I would just like to look at this Eastern European tornado situation, because it's one, and the winds, it's one I'm unfamiliar with. And the wind farm aficionados may want to look at your region. Whoa, this could be a good region here.
We also have a program, Climate Control, where we collect the eyewitnesses for the extreme weather events. And we have really massive testimonies of people who witness that. And the bad thing that it's that the roofs and all constructions are not designed in order to stand these horrible tornadoes. And it's really harmful for people. So I think it's,
tornadoes, and they're largely unpredictable. Tornadoes are just the worst. They're largely unpredictable. You can see hurricanes coming, at least a week in advance or something like that. But the tornadoes are just the worst. And it's the construction standards that are required to withstand a tornado are really huge. You may need to do that for administrative structures and hospitals and whatever, but for people's homes, I guess you just, need to have a tornado cellar and hope for the best. I don't know how you can protect individual homes from tornadoes. These are one of the hardest things to predict, from a weather forecast point of view. But this is a very tough one. And I was unaware of this increase in Eastern Europe and what might be causing that. And it could be, I don't know. But like I said, I'm interested in it. So I'd appreciate a follow-up email.
Yeah, thank you. We will find
all the warm states of France, Spain, all of those, Greece, Italy, where they usually, but they do see tornadoes, but they don't seem to be as intense. Now, if you look at them, it seems like they go in, like herds. They go from Atlantic towards the land, and again, they go in numbers, like 5 or 6 of them in a row, or even at the same time.
Yeah, well, the outbreaks like that are fairly common, where you get multiple tornadoes. We've had 1974, there was some crazy super outbreak in the US, like 200 or I don't remember the number, but some crazy number of tornadoes. So these kind of super outbreaks, we've certainly seen them in North America. And I would expect more in the center of the Eurasian continent that you would expect more tornadoes, not so much in Western Europe. But again, it's something that I don't know so much about, but this conversation
They seem to be living in Mediterranean these days. If you look at them, they all go along the Mediterranean Sea and Black Sea. That's the main area of them now.
Oh, okay. That's interesting. Yeah, like I said, it's something that I've just not been aware of. Concerning.
Yeah, for sure. And since we touched this topic about the weather prediction, we heard several opinions of the specialists saying that it's getting more hard to predict weather. And at the same time, we have like part of our team, they are captains on the big ships. And what they are noticing that it's getting quite hard to just the changes occurring so fast, and they did not observe it before. It's just like eyewitness observation. And like, do you see something like that in weather predictions, or everything is absolutely like according to the rules and everything works?
Well, if you look back far enough, you will find periods of crazy weather. There was a lot of crazy weather in the 30s and the 50s. A lot of records, crazy storms, records set and whatever. And it was clusters in the 30s and the 50s. And then, it was quiet in the 60s and the 70s. And so, again, a lot of this is tied to these multi-decadal ocean circulation patterns where you just get into periods when the weather's crazy. So, since about 2015, we've been in a regime with crazy weather. I assume that will flip at some point where we'll get into a regime with quieter weather. Again, it was the Pacific Decadal Oscillation and the North Pacific Gyre Oscillation were sort of conspiring to produce some craziness in the North Pacific, which had sort of bad ramifications for weather. It's just these sort of circulation patterns that get locked in and provide some nasty weather, and then you get some other periods when it's calmer. We see this so much with the hurricanes, where it's so much tied to what's going on with the Atlantic circulation patterns. But you see it with a lot of other, droughts and floods, and a lot of weather systems really are driven by these multi-decadal scale ocean circulation patterns.
Okay, which data sets do you believe? Which data sets would you recommend us to study?
Okay. Going back to 1950, there's the European reanalysis, the so-called ERA5. It's a gridded global analysis of, all the data that we have. And I think that's best back to 1950. For a global data set. It's generally regarded as the gold standard. Going back further than that, there's various attempts to construct circulation patterns in the atmosphere and weather going back to 1900 or even back to 1850. How much confidence to have in those, it's hard to know. But again, I think they would provide the best overall picture that we do have. So these, what I would call reanalysis projects. The other thing to look at, if you're looking at something more regional, is to look at, the historical, the weather data record in your region, and that may not go back very far, but looking at just newspaper articles of extreme weather events and ship reports. And there's a lot of reconstruction that gets done based on what I would call non-measurement information. And there's a group in the UK that is trying to take all the handwritten data and ship logs and whatever and trying to turn that into a real data set. In the US, there's a few people who are trying to reconstruct severe storms, in the 1800s and even 1700s. And so there's a wealth of information out there that the people to actually turn it into knowledge, it requires a lot of work. So depending on which problem you're interested in, but these reanalysis products are really the starting point. They're freely available. It's internally consistent data that is probably the best starting point for when you want to look at data about the climate.
I just would like to ask you two final questions, and just that, taking into consideration the situation on the planet in different aspects, how important do you think it is to unite people?
Well, I think uniting people is very hard. I think we need to let the local states and countries figure out how to secure their own self-interest in terms of pursuing their well-being and taking care of their local environment. So I actually like the bottom-up kind of solution rather than these top-down solutions. But I think we can unite people in terms of values, that we need to value, the environment and the ecosystems, and that we need to understand that there are cultural and regional differences in terms of how we engage with our environment and where we're at in terms of human development. What I'm very concerned about is trying to lay too much on like Africa and India in terms of when they're just trying to survive. Sometimes all this environmental stuff, it seems like a pastime for elites, rather than when you've got people on the ground that are doing their best to survive, and we need to help them figure out how to develop so they can, take better care of their environment. The people who are prosperous tend to damage their environment less. When you're just trying to survive, anything goes. So we need to figure out how to promote global prosperity and well-being. And so trying to unite on some values, to me, is better than trying to unite on a emissions target or something like that. We just need to allow these countries and states or whatever the vision is to figure out how to best secure their well-being. And we need to be, figure out people who are, the wealthier countries need to figure out how to support these less developed countries, so that we can, if we raise the level of human development, we will reduce the degradation on the environment. I mean, that's been shown time and time again. So to me, that's the best thing that we can do.
Yeah, thank you very much. And just related to the values, is that what is your opinion, how important it is to change the format of society from consumeristic to the creative, where the human life is the highest value?
Oh, yeah. I mean, for sure. I mean, that's what we should be valuing. And I think that's implicit in a lot of but some of these targets are really against humans. So no, I agree, valuing life and valuing ecosystems. I mean, these are the fundamental values, but sometimes we lose sight of those values when things get too global and profit and short-term profits and things like that. So I like decentralized approaches. You have some high-level values, and people just try to figure out what makes sense for them. You give them freedom, and everyone should have freedom, and then wealthier countries can help with help provide additional opportunities where they're wanted. And I think that's what we can do. The whole UN top-down thing, I'm not a fan of. So, rethinking how we can all survive together on planet Earth while recognizing, cultural and political differences. We just need to figure out how to do that better. And by top down and any kind of coercion, no, that's not going to help.
Yeah, thank you very much. Thank you very much, Professor Curry. And we're so much with you. And essentially, this point of view we are sharing as a team of Creative Society Project. And it was a real pleasure to talk to you. And seriously speaking, we all have a huge power. And our biggest power is in our values. And when we start with our hearts and we understand that another person in front of me, he has the same heart, the same soul, and his life as important as mine, I think it's where the change starts and unification starts. And we are really grateful to have you here, and we invite all our viewers to join our conference. Thank you very much.
Okay, well, thank you. I look forward to interacting with you in the future.
No lie lasts forever. Truth always triumphs. Now is the time for the truth. We will give you the facts of historical deception of all of humanity. In the year 1992, a 12-year-old environmental activist, Severn Suzuki.
I am fighting for my future. Losing my future is not like losing an election or a few points on the stock market. I am afraid to go out in the sun now because of the holes in our ozone. I am afraid to breathe the air.
The year 2018, a 16-year-old eco-activist, Greta Thunberg.
How dare you! You have stolen my dreams, my childhood, with your empty words. Lie on my generation, sucking hundreds of billions of tons of your CO2.
Interesting, isn't it? An old song written by the Cooks of Lies has been played again after 27 years. So what is the reason for such ardent performances by young eco-activists? In 1989, the Montreal Protocol was signed. The major scarecrow for people was the ozone holes. This scam destroyed the world's refrigeration industry and allowed billions to be made on this swindle. The ozone holes did not disappear, but the pockets swelled with dollars. 97, the Kyoto Protocol was adopted. The main problem is the infamous CO2. Greenhouse gases are now a new commodity. As the total climate finance average in 2019-2020 alone amounted to $632 billion US. A new global scam that is profitable for those cooks in the kitchen of lies. These subhumans exploit children, pleading for sympathy. Aren't you sick of it? To slurp down a stinky broth of lies and pay for it with your hard-earned money. The climate fight today is a big, cruel business. We are forced to toil away for food and shelter and to pay for air. The climate attacks and kills us mercilessly. It spares no one and takes no money. Cataclysms are escalating rapidly, and they are becoming stronger and more synchronized. Let's not be silent any longer. It's time for the truth. It is time to act.